Okay, here's your final exam review for Calc for Business. We start off with some limits. In this case, we're looking for the limit as x is approaching a for f of x. Here's a graph of the function f of x, some random function. Here's a right here. So if we're approaching a, we're approaching a from both sides. And we want to make sure we're getting the same y value that we're approaching. Well, if you look, as x is approaching a from the left-hand side, we're essentially traveling along the function this way, and the y value we're getting closer to is this y value right here, which would be c. So the limit as x approaches a from the right-hand side for f of x ends up being c. Now, if we approach a from the right-hand side here, we're basically traveling along the function this way and getting closer and closer and closer to the y value that's right here, which would be, if you follow it over, b. So the limit as x approaches a from the right for f of x is b. So since these are not the same, then we would say that this limit right here, as x approaches a for f of x, does not exist. So for this limit, we're going to do a little more computational method of doing it. In this case, we're looking at the limit as x approaches 4 for this function. We don't have the graph to look at. So in order to do this one, we first look to see what would happen if we plugged 4 into the function. Well, you see right away, if you plug 4 in, the denominator would be 0. Also notice if we plug it into the numerator, that would also be 0. And 0 over 0 is not 0, it's not 1, it's something we call indeterminate. What this tells us, though, is since we plug it in the denominator and denominator is 0, we can't just plug 4 in. So what are we going to do? What we're going to do here is look at the function itself. And I know that I can factor the numerator as x plus 4, x minus 4. The denominator being x minus 4. I could cancel these x minus 4s, simply giving me x approaches 4 of x plus 4. Now I got to the point where I can plug 4 in which case I'm going to get 8, and there's my limit. This one's a little different. If you look, x is approaching infinity. So when x approaches infinity, we treat this a little bit different here. In this case, this is a rational function. When you're taking the limit of a rational function as x goes to infinity, it's all about the degrees of the numerator and denominator. If you notice, the degree of the denominator is bigger. When the degree of the denominator is bigger, this limit simply is 0. Because this function has a horizontal asymptote of y equals 0. If the degrees were the same, let's say this was an x cubed over an x cubed, when the degrees are the same, we look at the leading coefficients, in this case 1 and 1, and we would divide them, and that would be the answer we would get. And if the numerator had the bigger degree, let's say that numerator was, I don't know, 5, and the denominator was 3, then the answer here would be plus or minus infinity, depending on whether we're getting a positive or negative value as you go to positive infinity. So in this case, though, for this example, we had the denominator had the bigger degree, and when the denominator has the bigger degree, the answer is simply 0. No real work to show, and we could do some computation here, but I would prefer you to be able to just look at this and tell me the answer. Okay, here's another one. If you look, we go to plug 6 into the function, it would make the denominator 0. But notice it's not going to make the numerator 0 because the numerator is 1. So we have to treat this a little differently. In which case you have to realize that when the denominator is 0 of this rational function but the numerator isn't, what 6 is a vertical asymptote. And if it's a vertical asymptote, as you approach 6 from the right, which is that plus sign says from the right, your function has two options. The function is either going to go up to positive infinity or down to negative infinity. And you just need to figure out which one it is. So the answer for this is either going to be positive infinity or negative infinity. So how do we decide which one it is? Well, the way we decide which one it is we simply look at what happened if we plug in something on the right side of 6. Right side of 6 means bigger than 6. So if I plug something bigger than 6 here and I subtract 6 from it, I'm going to get a positive value. This is always positive, so if I have a positive over positive, I know whatever answer I'm going to get out of this thing will be positive. Well, if my options were either positive or negative infinity, that tells me that positive infinity had to have been the answer. So this one we have to differentiate the function. This should be real easy. Polynomial differentiation should be something you should do in your sleep at this point. So if you look at this, y prime would be 20x cubed minus 6x squared minus 2. Very simple to do using your basic rules, power rule, constant multiple rule, sum and difference rule. Okay, here we want to find the equation of the tangent line. Okay, now we have a function, in which case we're going to want to find the derivative of that function, which will be easy, 5x to the fourth minus 9x squared minus 2. And this will help us find the slope of the tangent line at this point. So if we want to find the slope of the tangent line at 1, negative 1, we're going to have to plug 1 in here for x. So we're going to find y prime of 1, which would be 5 times 1 to the fourth minus 9 times 1 squared minus 2. So 5 minus 9 is negative 4. Negative 4 minus 2 would be negative 6. This right here is the slope of your tangent line. Now that's just the slope of the tangent line. This wanted to find the equation of the tangent line. So next thing we're going to do is we're going to use y minus y1 equals m times x minus x1. And we're going to go y minus negative 1 equals negative 6 times x minus positive 1. We're just using the point and the slope here for the equation. So we get y plus 1 equals negative 6 plus 6. Negative 6x, sorry, plus 6. Move some terms around here. You could write this as y equals negative 6x plus 5. You could write this as 6x plus y equals 5. I mean, different ways to write the equation of a line, slope-intercept form, standard form. I don't really care. You should be able to do both very easily. All right, here we're going to differentiate the function. This would be really easy. This is going to be a quotient rule 1. So f prime of t, the derivative of the numerator is 1 times t squared plus 6 minus t times the derivative of the denominator is 2t all over the denominator squared. So what do we end up with? T squared plus 6 minus 2t squared all over t squared plus 6 squared. So t squared minus 2t squared, that would give us minus t squared. So 6 minus t squared over t squared plus 6, all squared. Can't simplify this anymore. There's your answer. Right, here's another derivative we want to do, in which case we're going to have to use the product rule. So if we're going to take the derivative using the product rule, derivative of the first is going to be x, which is 1, times e to the negative x to the 7th, plus x times the derivative of e to the negative x to the 7th. So it's an exponential. You take the derivative of exponential by writing the exponential over again to the 7th, then multiplying by the derivative of the exponent, which would be negative 7x to the 6th. So combine these two here, and we end up with e to the negative x to the 7th minus 7x to the 7th e to the negative x to the 7th. Here's another product rule 1. Derivative of x to the 9th is 9x to the 8th times log x plus x to the 9th times derivative of log x is 1 over x. So we get 9x to the 8th log x plus, this can simplify into just x to the 8th. And there's your answer. Here, this is our typical chain rule problem. So if we're going to take the derivative using a chain rule, we're going to do the outside first, which is the power part. So we pull the power out, the new power is 3. The inside stays the same. Then we multiply by the derivative of the inside, which is 8. Simplify a little bit, I can multiply the 8 and the 4, which would give me 32. 8x to the 5th, all to 8x minus 5, sorry, all to the 3rd. And that's the best you can do with that one. There's really not much else you can do. Otherwise, you can multiply that out, I guess, but nobody wants to do that. So we're going to leave our answer like this. All right, here's some implicit differentiation. So the way we're going to do it is based off of partial derivatives, which is what we talked about earlier in the semester. First thing we have to do is set this equal to 0. So I'm going to rewrite this as x to the 6 plus y to the 6 minus xy equals 0. Then I'm going to think of this right here on the one side as my capital F of xy function. It's a function of two variables. So if I want to find the derivative of y with respect to x, I can do it by saying negative fx over fy. And what that is the partial of f with respect to x, the partial of f with respect to y. So the way we do that, so we have negative, is we look at this function and think of, okay, x is my variable, y is going to be treated like a constant. So I'm going to take the derivative of each one of these separately since they're added and subtracted. So the derivative of x to the 6th would be 6x to the 7th. Now I'm going to take the derivative of y to the 6th, but if I do it with respect to x, y is treated like a constant. So if this is treated like a constant, this is one giant constant, and the derivative of constants should be 0. Minus, now this derivative here. Again, if x is my variable and y is a constant, now y is multiplied by the x. That y is a constant multiple, which we pull out. So in this case, we're going to just take the derivative of x, which is 1, multiplied by this constant multiple, we end up with negative y. Do the same thing again, but now switch your roles. Y is your variable, x is your constant, which means x to the 6 is 0. Y to the 6 would be 6 y to the 5th. And I mess this one up over here. This would be to the 5th. Okay, you pull the power out, the power is 1 less, not 1 more. So that's the 5th power right there. All right, back to this one. 6y to the 5th. And then this one should end up being minus x for all the same reasons. X is a constant multiple, y is the variable there. So if I rewrite this, I don't have to write these zeros. I would have minus 6x to the 5th minus y over 6y to the 5th minus x. And this negative outside the whole thing. You can move the negative to the numerator or the denominator or leave it out. I don't really care. I like to just leave it outside the fraction. Okay, so this one wanted to figure out where we're increasing and decreasing and label the intervals. So in order to do this, first thing I'm going to do is take the derivative. The derivative would be 3x squared minus 27. Next thing I'm going to do is figure out where does the derivative equal 0 and where does the derivative not exist. Well, being that it's a polynomial, we don't worry about this. So just equal to 0. So you have 3x squared minus 27 equals 0. So that would give me x squared equals 9. So x equals plus or minus 3. So I have two critical numbers. Once I have those two critical numbers, I place them on my number line. And I'm going to look at the derivative. So I'm going to plug in negative 4, 0, and 4 into the derivative, and I'm going to see what happens. Well, if I plug negative 4 in here, I'm going to have 16 times 3, which is bigger than 27, so minus 27 would give me a positive. I'm going to plug 0 in, which would give me 0 minus 27, which would give me a negative. Then I'm going to plug 4 in, it's going to the same thing as negative 4, it's going to give me a positive. So what this tells me is that my function is increasing, then decreasing, then increasing. So I'll write this as f of x is increasing on the interval from negative infinity to negative 3. I could also write that as another way should be when x is less than negative 3. Okay. It's also going to be increasing from 3 to infinity, which I could write as x is greater than 3. And I could say f of x is decreasing on the interval from negative 3 to 3, which I could also write as x is between negative 3 and 3. Okay? So whether you write it in inequality notation or interval notation doesn't matter. Right, so this question is asking you to find the local and absolute extreme values, if any, and saying where they occur. Now, we didn't really talk about absolute extrema, so we're going to ignore that part of it. We're going to talk mainly about just the local, which is relative. So the way we do this is to take the derivative, which will give us minus 3x squared minus 6x plus 24. And we want to figure out when is this 0 and when is this not exist. Again, being a polynomial, we don't have to worry about does not exist. So minus 3x squared minus 6x plus 24 equals 0. That's a quadratic equation. Solve it however you want. Quadratic formula, factoring, completing the square, whatever will work. In this case, I'm going to factor out a negative 3. And that's going to give me x squared plus 2x minus 8. And then I'm going to factor as x plus 4, x minus 2. And so that tells me x equals negative 4 and x equals positive 2. So I have two critical values. Now the question is, are these maxes, mins, or neither? And there's two ways we can do it. We could do what we did in the last question, which is set up our chart. We got negative 4, we got 2. We can look at the derivative and figure out what happens in terms of increasing and decreasing, and then that can tell us max and mins. Or we can look at the second derivative. So if I found the second derivative, which in this case is really easy to do, negative 6x minus 6, I can plug these values into the second derivative and see what kind of answer I get. Either way will get you what you're looking for. I'm going to use the second derivative test. So I'm going to find f double prime of negative 4 and f double prime of 2. So if I plug these negative 4 and 2 into the second derivative, negative 4 is going to give me 24 minus 6, which will give me a positive value. 2 plugged in will give me negative 12 minus 6 will give me a negative value. So what this tells me, if it's on the second derivative and I get a positive, I'm concave up. If I'm concave up, I have a minimum. So negative 4 comma f of negative 4 is a min. And here this is telling me I'm concave down. Well, if I'm concave down, I have a maximum. So this tells me that 2f of 2 is a max. And when I say max min, I'm talking about relative. Relative max, relative min. Absolute is a little bit different. We didn't really get into that this semester, so we're going to ignore that part of the question. Okay, here we want to determine concavity. In order to do that, we need second derivative. So, first derivative would be 3x squared plus 12x plus 1. Second derivative would be 6x plus 12. We want to figure out where the second derivative equals 0, where the second derivative does not exist. Again, being a polynomial, you don't worry about does not exist. So 6x plus 12 equals 0 when x equals negative 2. So you have one value to look at here, so negative 2. We're going to look at the second derivative. So I'll plug in negative 3 and 0 into the second derivative. You clearly see when you plug negative 3 in, you're going to get a negative. When you plug 0 in, you're going to get a positive. If the second derivative is negative, it tells you you have a concave down picture. If it's positive, you're concave up for your function. So this tells me that f of x is concave down on the interval from negative infinity to negative 2 and concave up on negative 2 to infinity. What it also tells me is that the concavity changes here, so as far as inflection points go, if I can plug this point into my function, which I can because it's a polynomial, then this also tells me that negative 2 comma f of negative 2 is an inflection point. Okay, here we get a pretty simple indefinite integral, in which case we can integrate each one of these separately because of the sum and difference rule. So if I'm going to do the integral of x to the 1/3 dx minus the integral of 4x to the minus 2/3 dx plus the integral of 4 dx. Now, the x to the 1/3, we're going to use the power rule, so we're going to add 1 to that power, which will give us 4/3, and divide by the 4/3. This 4 is a constant multiple, so I'll pull it out. I'm going to do the power rule again here, which means I'm going to add to that negative 2/3, which is going to give me positive 1/3, and divide by it. And then here, this is just going to be a 4x, throw plus c on the end. The only thing we have to do is here we're dividing by a fraction, here we're dividing by a fraction. So I'll flip and multiply, 3/4 x to the 4/3. This will be minus 12 x to the 1/3 plus 4x plus c. Okay, in this one, we're going to rewrite these functions a little bit first. We're going to write this as x to the negative 5 minus x to the 5th minus 1/5 dx. Again, I can do each one of these separately because of the subtraction here and here. So x to the negative 5 will be x to the negative 4 over negative 4. X to the 5th will be x to the 6th over 6. And negative 1/5 will be negative 1/5 x plus c. We just fix this one up here. I'm going to write this as negative 1 over 4x to the 4th minus x to the 6 over 6 minus 1/5 x plus c. And we got our answer. For this one, we're going to have to use a little bit of substitution. If it was just the square root of x that we were integrating, we could write that as x to the 1/2 dx and then use power rule, but it's not. It's 8x plus 4. So I'm going to say let's let u equal 8x plus 4. Du is going to be 8 dx. But if I pull this out, there's not an extra 8 with the dx that I can use. So I'm going to swap that 8 to the other side by dividing it. And so what happens is this integral is going to become the square root, which is 1/2 power, of u. And then the dx is equal to du over 8. Well, the over 8 I'll pull all the way out as a 1/8. And so now what I have is u to the 1/2 du, which is basically the same as this. So now I can apply the power rule. So I have 1/8. This will be u to the 3/2 divided by 3/2 plus c. This will flip and multiply. And then the u will have to get replaced with what it was equal to in terms of x. So what I end up getting here is 2 over 24, which I'll simplify, 8x plus 4 to the 3/2 plus c. Now this can simplify into just 1/12. We have 8x plus 4 to the 3/2 plus c. And there's your answer. Here's another substitution one. Notice that the derivative of this is sitting right here. So if I let u equal x squared plus 2, du is 2x dx. So if this is my u, here's my du. So what this turns into is just simply e to the u du. And the integral of e to the u is e to the u plus c. Switch out your x's, which is x squared plus 2 plus c. And then we got our answer. And if you're not sure, what we could do is we can say, let's take the derivative of this e to the x squared plus 2 plus c. And we should get back to here. And we do, because if we took the derivative, we would rewrite the exponential over again. Then chain rule says we'd multiply by the derivative of the exponent. And the derivative of the c is just going to be 0, so it's not even there. So look at what we have, exactly what we started with. So there's our answer. Okay, another substitution. Notice that if I let u equal y to the 8th plus 5, the derivative of a y to the 8th is going to be a y to the 7th. It's going to be 8y to the 7th dy. So I have this y to the 7th dy, but I don't have the 8. So again, I'll swap the 8 over, divide it. And what I end up with is du over 8 for the y to the 7th dy. And this is u, so that'll be u squared. Well, to integrate u squared in the denominator, I have to bring it up to the numerator first, so u to the negative 2. Then again, I'm just going to use power rule, which will be u to the negative 1 over negative 1 plus c. Remember, add 1 to the power and divide. So then I end up with negative 1 over 8u, because I'm going to bring this to the denominator since it's got a negative exponent, u being y to the 8th plus 5 plus c. And there's my answer. Okay, now here we have a definite integral. So with the definite integral, we're going to do a lot of the same stuff we just did. And then we'll worry about applying the fundamental theorem for this piece. So first, I'm going to have to do the integral. Now in order to do this, I'm going to do u substitution. U equals x cubed plus 1. The derivative would be 3x squared dx. I have an x squared dx, but not a 3x squared, so I'll divide the 3. In which case I'm going to get the integral of du over 3. And this is going to be u cubed. Again, u cubed. I still have this 1 to 2, but remember this is an x value. This is an x value. So in that case, I got to be concerned with that when I'm dealing with these u's, but not right now. So I'm going to bring this u up. It's u to the negative 3 du. I'm going to integrate, which in this case now is going to be u to the negative 2 over negative 2. And I still have this 1 and 2. But again, these are x's. I can't plug them in for a u. So what I'm going to do is what we did in the previous examples. I'm going to go back to x here first. So this will be a negative. Let me erase this. This will give me a negative 1/6. U to the negative 2 is 1 over u squared, which was x cubed plus 1. And now I can plug in my 1 and my 2. So I'll plug in 2 first. So I have this negative 1/6. I'm going to plug in 2, so it's 1 over 8 plus 1 squared. Okay, minus, I'm going to plug 1 in, which would be 1 over 1 plus 1 squared. And so that gives me negative 1/6 times, this is going to be 1 over 81 minus 1 over 4. So find the common denominator. Common denominator would be 4 times 81. So the numerator, if I do this, I have this negative 1/6. I'm going to have 85 over 81 times 4 is what? 324. And then multiply 6 times that, and we end up with our answer. So what's that going to be? It's negative 85 over 419, so 1944.